And I want to clarify this mentioning of the operator less than is that your object, for instance, the value object, and customer was our value object in our map, does not need this operator. It's really the key that needs to support this operator to be able to used as a key in the map. Of course, integers can be compared by this iterator, operator. So this is why it was okay to use the phone, an integer phone, as a key. Of course, strings, if our key was a string right here instead of an integer, strings have overloaded less than operator. But if this was something more complex, we would have to provide that operator to the compiler before we can use it in the key. By the way, if it's a pair, pairs also support this operator. You don't have to overload it if you're using a pair. So there are quite a few possibilities, but sometimes if you really need to sort it by something complicated, your own data structure, then you need to make that data structure comparable by overloading this operator. Okay, so let's see some more examples of adding items to the map. Now, it's possible to, instead of using insert, to simply use the subscript notation like this. We have a mapping from string keys to an integers, and it's like age map. So we use we say Fred, and we specify the name, which is the key, and we specify that this key is pointing to the value. So you can see that we can now retrieve the value from the map, again using the square brackets, and we can use the square brackets in the situation where the expression requires an L value, which means modifiable value. So here we increment, and now we make it 46. Now realize that if this did not exist, right? If this key Fred did not exist in the map, this expression would automatically add new, put new item, put new pair of key and value into the map. So this is why more often than not I prefer to use find or count, because I really before I insert something, I prefer to have some kind of control over this. It's just like a side effect, you know. You don't. It looks like this is already present in the map, this name, and then we change it, but in reality, it's not. It's not there. So I prefer to use some kind of code that allows to check, either using the find or the count, to check the presence of this key and value pair in the map already. All right. So anyway, it's just you need to experiment with this code and get some look and feel, and of course to read a little bit more tutorial information to develop your own sense of what you expect from the map, how it behaves. But I just showed you most of the time, 90% of the time, I use this logic that I just demonstrated to you to manipulate the map and check for presence of the key and access individual elements. So count, we already seen an example of the count. We can use the count to do our checks. And iterators, of course, we also already use the iterator for the customer, but here we can type def, create the synonym for map that maps strings to integers in this sample, and name it map t, and then we can say, okay, we want to use constant iterator and name it map iterator type, and then we can create map by using this type def, and then we can say that starting from the iterator pointing to the beginning of the container and all the way through until it does not equal the ending of the container, let's increment this iterator. And this iterator, just like we used it right here, right? So this was an iterator that was accessing the second element in the key value pair, which of course is the customer object. In this case, again, first and second will be printing the string and integer in the map of this type, right? So just again, feel free to copy and paste these examples into your own sample program and try to make some changes here and see how everything works in your own experimentation. So map find, once again, we also demonstrated this map find already in our example. So find returns an iterator, and this iterator then we can look for and just use this iterator to continue using it with accessing elements. Insert, again, I showed you insert. My way of putting information in the map is to use insert, and insert requires a pair. So I've used make pair. Okay, so another very convenient place to use this utility function, make pair, and you just simply provide what is the first element of the pair and what is the second element of the pair, and it'll be happy to construct, basically derive the types from these two values and decide what kind of pair this is. And if we provided some good types, so the pair type will be matching the type of the item stored in this map, and now we can insert. So by the way, also insert will not replace existing items. So that's just something to be careful about. So because if you're thinking that insert will replace an existing element in the map, it's not going to happen. So for instance, let's just make this adjustment just to verify this idea. We can say that customer name. Okay, so we just say, okay, let's reuse this customer one more time. Customer name. Okay, and we reset it to something else like Alice. Okay, and so there's a different name, and we want to, if we try this again, just same line. Okay, and build this. So the phone didn't change, the customer did change, and if we run it, okay, with this change right here, you see that it's still Joe. Alice never. So basically, this was ignored. This second attempt to insert was ignored because the insert figures out that this is already on the map. Therefore, it just ignores this insert. Just something to be aware of when using insert. So you typically would want to use insert with checks like count, just to make sure that if it's already there, you may want to update it the other way. Okay, so but just be aware that this attempt to reuse this customer with the same phone value had no effect on the content of this map. Just be aware of this. Okay, so if you'd like to remove items, so you can use erase. So once again, erase needs a key from us, and we provide the key, and then it actually returns a Boolean result, whether the key was found or not, and if it was erased there, it will be non-zero, basically. All right. So in summary, container that holds unique pairs of keys and values is a standard map. the standard map is always sorted. If we added multiple items to our map of phone numbers and customer objects, as we tried in our example, they all will be sorted by the phone number. Or if we use any other map with certain key, they will be sorted. And obviously, if key is a string, then the keys will be sorted in alphabetical order. And there's another example right here that you can also copy and paste. It sort of like simulates also like a phone book, something that we've tried to experiment with, but this time it's just using the string. So we don't have a customer object. We're just mapping one string to another string. So both key and value are strings, and you can see that these are emergency numbers, and this is some kind of specific number right here. And so we're trying to build a phone book by simply entering phone numbers and what this entry description is. And of course we can say find, so we can look for values. We can also check the size of the map. Okay, and in this example we just want to verify that all the manipulation here resulted in size equals 3, and then we just create constant iterator that just loops through the map and prints the phone and the description, assuming that first entry in the map is the phone number and the second is the description. So it just prints. You can see the output of this directory, and notice that these values, the phone numbers, were specified as strings. So of course they're sorted in alphabetical order. So 4, 5, and 9 are all sorted right here, you can see in the output. So one final note about the map. So map maintains unique set of keys, right? Values don't have to be unique, but the keys are unique, always sorted. And you've seen this concern with the existing key, that something could be even ignored by the insert. It's all due to the nature of the map using unique keys. If you want to have a map with a possibility of multiple values for the same key, okay, then you use the multimap. But what is taking away from you is this operator, because the subscript operator requires a specific index, and of course most people would expect that that index would recover a specific value. Obviously, if you have one key that you have to specify inside these square brackets, and there are multiple values for this key, this is not a very logical solution. So this operator is taken away. Also there are some changes here. Insert will return an iterator, and we can iterate the same way, create a loop and go through everything, still supports the iteration, of course, using the iterator, but no order is assumed in the values themselves. So if you expect that the values would be sorted, that's the wrong assumption. Only the keys are sorted. The value is anything, okay? It can be really anything you can insert in the map, and it never looks or compares the values. As long as it can store the value, it doesn't care beyond that point. So the count can return now any size that corresponds to the number of elements with a given key. All right, so this is why count in the map, not multimap, but the regular map, always gives you 1 or 0. Here it could be 0, 1, or more if in reality there are multiple instances of the values with the same key. And also find returns an equal range with the key. So something that you can find out, basically, what we can do is, if we expect that, for example, our mapping, this multimap, will contain multiple entries for this name, we can say map, give us an equal range for these keys. And this equal range returns back a pair. Okay, so for example, if this map contains some elements right here, so the map is populated, and when we say Fred is a key, we may find out that there are like 3 items with this name present, 3 elements already present in the key. So this result, which of course is a pair, right? So this is a pair, so it will be first and second. There are two elements in this pair, and so the first will be pointing to the first element with this key, and the second will be pointing to the next element, which is like a stop sign for the half open range. So this is where the second pair will be pointing to. And then in this loop right here, we just basically start here and advance forward, and we'll be able to print this, this, and this. And as soon as the iterator becomes equal to second, we stop, so we don't print this. So we'll be able to retrieve every element corresponding to the Fred inside this multi-map. And so equal range is quite useful when working with values that may have the same keys in the multi-map.